Hello everybody, and welcome back to the Poor Man's Chemist. In this video, we are going to be making vanadyl sulfate and ammonium vanadyl thiocyanate from vanadium pentoxide. Now, Vib's lab already did a video on making vanadyl sulfate from vanadium pentoxide, but in his video, he used sulfur dioxide as the reducing agent. When I checked the atomistry page for Vanadyl sulfate, it said that the same reduction could be accomplished using alcohol. So what we have in here is 4 grams of vanadium pentoxide, about 35 mils of 1.59 molar sulfuric acid. We're going for about a 2.5 to 1 molar ratio sulfuric acid to vanadium pentoxide, and I'm just using that because that's what Vibs went with. And according to atomistry, when you have more than 3 molar equivalents of sulfuric acid, you end up with some kind of acid vanadyl sulfate. And I don't know that we want that, especially given that Vibs seem to use molar ratio that was just a little bit below that. So I figured we would stick with what he went with. I've already given this reaction a try just to make sure that it works, and it does indeed work. It seems to be about as time consuming as his prep was, so you know. But given that you don't need any, sulfur dioxide gas is a lot easier. Somebody else had also suggested generating sulfur dioxide in situ with sodium metabisulfite, but there again, I mean, you got to constantly be, adding it if it's all used up and it's not generating any more sulfur dioxide. It appears to take a long time. I don't know. I don't have, this is the last of my vanadium pentoxide, so I just haven't had enough to play around with trying that method. But I mean, if you can just toss some ethanol in there, which there's 40 mils of ethanol in there, and smack a condenser on it and call it a day, that's a hell of a lot easier, in my opinion, anyway. So all we need to do is just heat this up and let it reflux. It's about 5 o'clock in the afternoon now, so it's not going to be done today. This reaction takes several hours. When I did this in the practice run, where I basically just did exact same thing, just half the size, it turned green within a pretty short amount of time. But then it didn't take it too much, like within just a couple of hours, it had turned blue. I let it reflux for several hours the next day, and it just kept turning a more and more vivid blue as time went on. You can add a little water in there. I don't know that water hurts the reaction in any way. I just went with as much alcohol as possible because it's easier to remove, and we've got to remove all the solvent at the when we're done with this to get the crude product, purify to get our pure product at the end. So, again, just going with what's easier here. Okay, so I guess a little bit under an hour after I filmed the last clip, I shut down the heat and put this up because it was getting kind of late. I just got home from work and I'm about to let this thing go for several hours now. But before I turn on the stirring, I thought I would let you guys take a look at it. This is exactly what happened the first time I did this reaction. It turns out green at first. I don't know if that's good, bad, or otherwise. I have no idea what that is. It'll turn blue later. So I'm just gonna get the stirring going here and we will let this do its thing for a few hours. I will come back and check in once I'm ready to shut it down for the day and you guys can take a look at it. And before I go, there was a little accident that happened just now where the heat was on this thing on the hot plate and I turned it on, or rather plugged it in, and I didn't realize that the heat was still on. This damn crystallizing dish had to have been at a couple hundred C when I poured water in it, not realizing that that the heat was on. And man, this thing held up to it perfectly. Not a hint of a crack. So I don't know who this company is or what kind of other shit they make, but clearly they make good crystallizing dishes. Anyway, I will come back in a few hours when I'm ready to shut it down for the day. Okay, everybody, it is the next day, and as you can see, our solution has a distinctive blue color. I refluxed it for somewhere around 3.5 hours yesterday before it started getting late and I started getting tired. Starting it a little earlier today, so I'm going to let it reflux some more, and then once it's gone for a few hours, I think we can go ahead and stop it there and just, go ahead and do the rest of the prep. I'm noticing a really strong fruity smell when this stuff is going. This is really putting me in mind of a Jones oxidation, right? The vanadium is getting reduced, the alcohol is getting oxidized, and so far as I can tell, that fruity smell is acetaldehyde. I don't know. I've never smelled acetaldehyde before, so I'm not 100% sure what it smells like. I mean, that makes sense. I mean, if the alcohol is reducing the vanadium, it must be getting oxidized in the process. So it's not really a surprise that it's chucking out acetaldehyde, but I just think it's kind of interesting. I wonder if this has any synthetic utility in organic chemistry. I'll have to look that shit up. Anywho, I will come back once this is reflux for a few more hours, and hopefully we'll have a decent yield by then. Alright everyone, so it's reflux now for about a total of 10 hours. This happened last time where the vanadium pentoxide went from its normal bright color to almost like a dull yellow color. I don't know what that means. It just seems to happen after it's refluxed and stirred for several hours. But you can see where it's swirling on the surface there, where our solution is now a vibrant blue. You'll be able to see it a hell of a lot better after I filter it here. What I'm going to do is I'm just going to vacuum filter this shit through a bed of sea light. You don't have to do it that way. I'm just doing it because it's a lot easier to capture all of these fine particles. And it can just be discarded. Vanadium pentoxide is not, the stuff of nightmares or anything. So yeah, I will come back once this has been filtered and we've got our solution of Vanadyl Sulfate and we are ready to move on. Okay, people, here is our beautiful blue filtered solution of Vanadyl Sulfate. What we need to do now is evaporate this down till we get a kind of gummy residue. We don't want to get it too hot because from what I understand, it will break down into, I think what atomistry called hypovanatic oxide. I don't know. It's on the screen. I'll put the formula up there of what it's supposed to turn into. So I've got it over a hot water bath now, hopefully to become a boiling water bath here soon. A lot of that is alcohol and gotta be acetaldehyde because it smells like being dropped into a fruit bowl. So it shouldn't take too long to evaporate, and then that'll just leave us with the water. Hopefully this won't take too terribly long. So I will come back when we have our gunk and we are ready to move on to purifying that shit. Okay, everybody, so I have evaporated this down until it is kind of a thick blue liquid here. Yesterday, I noticed that kind of around the edges here where the heat was drying it out, or if it's just left exposed to air, it will turn green. According to Adam, maybe that shows up there. Is it starting to turn there? A little bit. And see that little spot? Maybe you can see it is getting... it's probably not showing up, but it looks kind of greenish in real life. Anywho, atomistry says that the green stuff is vanadium dioxide. What we are going to do now to try to separate out our pure Vanadyl sulfate is extract it into acetone. Much to my astonishment, and I asked ChatGPT what organic solvents this shit would dissolve in, it listed methanol, ethanol, and acetone. Well, we've already seen that it's pretty damn soluble, actually, in methanol and ethanol. But according to the program, and this mimics what I saw in the test run, it's not super soluble in acetone. It's somewhat. We may have to extract it a few times and let it heat up. So I've got the hot water bath heating up over here. Got a full container of acetone there. And what I figure we'll do is once this gets to temp, I will just put it up there. We'll put some acetone in here. We'll stir that shit up. We'll let it warm up, decant it, evaporate it, and that will give us our pure Vanadyl Sulfate. Now, I asked ChatGPT to recommend some coordination compounds of vanadyl ion. It gave me a whole list of them. There were some that haven't been done on YouTube that I could find. Maybe we'll do that. I don't know. I haven't decided yet. Atomistry has a huge laundry list of vanadyl compounds too. I want to turn this shit into something, man. I don't want to just do vanadyl sulfate because other people have already done that. You know, what good's repeating what somebody else has done exactly? That's fucking boring. So, we'll try to come up with something cool to turn this shit into to wrap this up with. But anyway, I will come back once I've extracted some of this shit into acetone, and just so you guys can take a look at what it's like, and we'll evaporate that down, and then we'll make some other shit with this and wrap this shit up. Okay, everybody, so here is our stuff that was extracted into acetone, kind of. Most of it ended up kind of clumping up at the bottom as this blue goo. And this is only the first acetone extraction. When I first poured it in there, it got very cloudy. And I'm like, oh man, what the fuck went wrong? So I pour it off into the crystallizing dish, and I pour more acetone in there, and I'm stirring it up. And the next batch of acetone brought off this kind of green shit. Well, if atomistry is right, green shit is the oxide. Maybe it's soluble in acetone. I don't really know what's going on here. But there's definitely a greenish solid at the bottom that is not like our stuff. So after I did that, all of our product turned into this kind of oily goop. And I just kind of scooped it out and put it in here. Now, the crystallizing dish was dirty with that goop, and it dried out on the bottom because the dish was still warm. And I was kind of just stirring it up with a glass rod, and it turned into a, powdery solid. And I added some water to it, and it dissolves freely, gives us a nice blue solution. So I guess the goop is our stuff. Why the second extraction turned colors and took this shit off, I don't know. But the first acetone extraction and the blue goop appears to be our shit. Beats the fuck out of me, people. I'm making this up as I go at this point. I'm going to let this sit over the steam bath. I've turned down the temperature some because I really don't want any more of the shit breaking down to the fucking oxide, which seems to be very easy to accomplish. And I'm just going to let it dry out. And we're going to let it do its thing. And when it's completely dry, I will come back and then we should have pure-ish Vanadyl Sulfate at that point. I'm guessing. I don't know what the fuck else it could be. So, I don't know. We'll see what we get then, and we'll go from there. Okay, people. So, it is the next day, and this is our Vanadyl Sulfate. I dried it in the desiccator overnight, ground it up into a powder, and got just over 3 grams of it. The yield probably should have been about twice as high, but I kept having to do experiments with this stuff, constantly testing it to see as I'm drying it out, and it kept turning green. Is it breaking down? Is it okay? I mean, I only heated it as high as 60°C, and the shit still turned green when I dried it out. But I discovered if you add water to it, it will turn back to a nice light blue that looks exactly like this. And exactly like this, if you put it in water, at first it will not dissolve. It will form a suspension. If you warm up the water, it will go into solution nice and clean, and you get a nice, beautiful blue solution like this. Now, one thing I do want to point out on camera, this looks more blue than it is in real life. In real life, this is more of a light turquoise color. Why the camera sees it as a more vivid blue and not a pale, I don't know, almost like a bluish green. I do not know. Looks exactly what it looks like when I've seen pictures of this stuff. And if other cameras see it the way my camera does, that would explain why it looks that way. Now, I went ahead and I played around with this stuff, and I was originally going to turn all of this into some other Vanadyl compound, but as I began playing around with this stuff, I discovered that, most of the stuff that precipitates out, if it precipitates at all, comes out as a very fine precipitate. Take this one, for example. This is ammonium vanadyl thiocyanate. It is exactly what it's supposed to be, a very dark blue compound. It is a solid. I mean, the liquid's opaque, but it is in there as very, very fine particles. I mean, this shit makes barium sulfate look, downright easy to remove from water. This shit stays suspended. I mean, it hasn't settled out at all, no matter how long I've let it sit here. This is Vanadyl Sulfate combined with some disodium EDTA. This one precipitates out a little bit better. I mean, you can get a pretty good idea of what it looks like. It's just kind of a light blue powder. I think this one is the more interesting one. Nothing precipitated here, but this is Vanadyl Sulfate combined with dithizonate. And it turned into this beautiful green solution here, which doesn't look like it looks real green on camera. But in real life, that is a nice, vivid green color. So yeah, I'm pretty much just going to leave it at this. We'll just stop here and we'll just be happy with this. Some other people had said make Vanadyl acetylacetonate, but too many other people have already done that. So here's some shit you hadn't seen with Vanadyl ion before. So anyway, if you guys like this video, give it a thumbs up. And if you didn't like it, well, I mean, my God, it's a fucking transition metal. What the hell does it take to fucking please you? Subscribe, comment, share the video, donate a few bucks, please, if you're really enjoying this. This is very expensive stuff to do. And until the next one, y'all, I will see you later. That's pretty goddamn neat.